You might have seen that sometimes after a long conversation, the LLM sometimes forgets the initial part of the conversation, the initial questions that you have posed, or the initial context of the conversation. So why is that? That is because of something called the context windows in LLM. So what does the context window even mean? Let's take a look at a conversation between myself and Gemini 2.0 Flash model here. So I asked a question. I'm currently reading the Wheel of Time book. What do you think of the book? I have not read Wheel of Time yet, but I'm hoping to get to it at some point. But this question yielded in a long, super long response here. So how is this conversation between us and the LLM working here? So what happens is when we type in this text to send to the LLM, the text is first converted into something called tokens. So as you can see, I pasted the text here in Tick Tokenizer, which lets you get the token count for the text that you have entered. So I have the text here, and as you can see, the text has been split. I has been split into just the letter I. Am has been split into like space and am, and that represents the 939 token highlighted below. So on and so forth. All the words have been split into something called tokens. All of these are single words. It's split correctly into single words, but you can have subword tokenization as well. So for example, I'll do assassins, and you can see ins. So since this has been I spelled that wrong, but that's fine. So you can have subword based tokenization as well. So when we type in a question like that, it converts it into tokens and then sends it to the LLM. The LLM then understands the token and sends its own stream of tokens back to us, which is then converted into text for us to understand. At the end, it has a specific token that specifies when it has finished typing, which is right here. So then I asked the second question. I'm reading the first book. I just got started. So as you can see, it got the context that I'm talking about the Wheel of the Time book. So how did it know that I'm talking about this book? That's because the next time I ask the question, all of the previous conversation is also sent to the LLM again. So that's what this looks like. We have question, answer from LLM, question, answer, and the next time we ask something, all of this previous question and answer is sent to the LLM again. So this question, answer could get super long, as you can imagine. Every LLM has something called a context window. That is the maximum amount of tokens that a LLM can handle. For example, Gemini 2.5 has a context window of 1 million tokens, which is actually quite a lot. Let's assume that we have a large language model with the 2048 tokens that it can accept. So suppose our tokens exceed 2048. What would happen is the LLM will start forgetting the initial bits of token as new information keeps being added to its context window. So that is why your LLM is forgetting things, because as you keep on asking new question, there's no space in the context window for the older questions to exist. So the LLM kind of infers what the older questions could be, and that's when it starts hallucinating. So one thing to note is that it's not just the question and answer that is added to the context window. What else could be added here? We have the system prompt, which is something that might be hidden. We have additional documents that the user passes in. For example, you pass in a PDF, pass in an image, you pass in some code. That can be any additional document. All of that is passed through the context window. In case I forgot to mention, this is the amount of tokens that we are sending to the LLM, 17, which is quite less. A model like Gemini 2.5 will have a context window of 1 million tokens, which is quite soon. 2 million coming soon, which is quite a lot. There are some disadvantages with some large context window models like this as well, which I'll talk about in a bit. So what if I open up a new chat with the LLM and I ask a question? Can you tell me about the first chapter? So it does not know the name of the book. That is because when we start a new conversation with a model, the context window is wiped out. So there's nothing left in the context window, and that is why we see this, because the LLM does not know what book I'm talking about here. So one thing you have to understand is the application is what is maintaining the state of the conversation. This is the chat between myself and Gemini. You can think that it's interacting with an API which fetches the previous conversations from the database, which it might have stored the data in, and then it sends my current chat and my previous chats to the LLM. The LLM itself is stateless. It does not know anything about your conversation. The entirety of your conversation is sent to the LLM over and over again, and that is why it's stateless. So why cannot we have a super large context window? That is because it might require a lot of computing power. As I just mentioned before that it's stateless, every time you'll have to pass in the whole conversation over and over again, which means it requires a lot of energy. One potential solution could be to summarize your previous conversations and pass it to the LLM. That might help with the limited context window sizes. Even with huge context windows, what happens is LLMs right now are effective only at the beginning part of the conversation and at the end of the conversation. It really pays attention to these two parts of a conversation. The middle part, it really does not pay much attention to it. That's because of its self-attention mechanism, which is out of the context of this video, the explanation for that. But you just understand it does not really pay attention to the middle part. There might be some concerns with the safety of this because there might be some prompt injection techniques that some bad actor has used, which might exist at the center of the conversation. If the LLM is only paying attention to the beginning and the end, whatever guardrails that we have put in might not come into effect, which is not good. So the last thing that I want to show you is the memory feature that ChatGPT has. So you might wonder, hey, like the ChatGPT model is better than all the other models because it has this unique features where it remembers things about me. Well, that is not something super unique. It again works with the context window. As I mentioned, the LLMs themselves are stateless. So as you can see here, ChatGPT has this manage memory option where it shows you the list of things that the ChatGPT client remembers about you. So what happens is if you type in something that ChatGPT thinks is something that they should remember about you, it will save that information in its client. And the next time you ask a question, the ChatGPT with its system prompt, your question, it will pass in the entire memory into the context window. So that is how the ChatGPT is able to manage memory in the application. Well, I hope you learned something today. Like and subscribe if you want to see more. Thank you.